Okay, here we have a lesson on the atom, which is really revision from GCSE levels, but it forms the fundamentals of all the rest of chemistry. So we're going to make sure that you haven't forgotten it and you can use it in the remaining lessons. So let's start off with checking the learning outcomes for this lesson. Firstly, we want to be able to understand that an atom consists of a nucleus in the middle, which is small, and that would contain protons and neutrons, and the nucleus is surrounded by electrons in shells and subshells and orbitals. Also, we want to be able to describe the properties of protons, neutrons and electrons in terms of their relative charge, that's the charge relative to each other, and their relative mass, using atomic mass units. As well, we'll want to remind ourselves of the meaning of mass number, sometimes annotated as A, and the atomic or proton number, sometimes annotated as Z. So we'll remind ourselves of the meaning of those two terms, as well as we want to be able to determine the number of protons, neutrons and electrons in atoms and ions using the mass numbers and proton numbers. Okay, so first of all, let's start out with, hang on a sec, we've got one more lesson objective. We do also want to be able to explain the existence of isotopes. So let's crack on with a review of the structure of the atom. So I think you'll remember that we have a nucleus in the middle of an atom, made up of protons, here in green, with the P inside a little circle to model the proton. And you also in the nucleus have neutrons here in black, with N in the middle of the circle. So that's supposed to describe our nucleus, and the nucleus is going to be surrounded by electrons, given here in red. So those electrons are in shells, and there are a certain number of electrons allowed in each shell, and we're going to go through that in due course. Okay, so summary is we have electrons in shells that surround a nucleus that consists of protons and neutrons. And in a neutral atom, we would of course have the same number of protons as electrons. Okay, so as well, let's have a look at this little table here. This gives us the relative masses of protons, neutrons and electrons, and also the relative charges of those three subatomic particles. So relative mass is given in these whole numbers, which are atomic mass units, you'll remember. And we do that because to give the masses in grams would be such unusual numbers that would be quite cumbersome. So we use atomic mass units instead. And even as far as A level is concerned, we can say that the mass of a proton is the same as the mass of a neutron. And that's given a mass of one atomic mass unit. And the electron at GCSE, you probably were just given the fact that the electron has no mass. It does have a tiny little bit of mass, and compared to a neutron, it would be 1/2000th of a neutron, the mass of that electron. Okay, so moving on to relative charge, I think you'll remember that the neutron is neutral, whereas the proton has a positive charge and an electron has a negative charge. Okay, so that's the basics of the structure of the atom. So that enables us to move on to mass number and atomic number. And what we can do is we can just use a big X to be a generic symbol. Okay, so I'm just going to write symbol, as you see on the periodic table, in brackets there. And when you look at the periodic table, you notice a big number, which we're going to call A, because the mass number, rather confusingly, is given the annotation A quite often, and the atomic number, or the proton number, is given Z. Okay, so let's just label those. I'll change color just to make it a little bit clearer. So the A is the mass number, and the Z is the atomic number, and the mass number is the number of neutrons plus the number of protons, and it gives the mass of the atom. And the atomic number is just the number of protons, and that actually defines the atom as a particular element. All right, so the element is an atom with a certain number of protons in it. So let's just make this clear by looking at a few examples. All right, here we have a table with 3 examples in it. We've got lithium, bromine, and magnesium. So let's look at lithium first. So we can see the nuclear symbol. The nuclear symbol is just the element symbol, which is Li in this case, together with both the mass number and the atomic number. So we have a nuclear symbol there for lithium, and we have a blank here to fill in atomic number. So the atomic number Z is the number of protons, and that is the bottom one, and so we can fill in a 3 here from the 3 in the nuclear symbol. And the mass number is the bigger number, is the number of protons and neutrons, you'll remember. So we can fill in a 7 here for lithium. So as we've described, the atomic number gives the number of protons, and we've listed that as 3, so we can write our 3 in here. And these are all neutral atoms. We can tell because there's no charge given in the nuclear symbol, no pluses or minuses. So in that case, the number of electrons must be equal to the number of protons. So we'll put in a 3 here. And the number of neutrons, right, it's a simple bit of maths, that if you've got 7 neutrons plus protons, and of those 7, 3 are protons, right, then the number of neutrons is simply your 7 take your 3, and that's going to give you 4 neutrons. Okay, so that's a nice easy one because the numbers are small with lithium. Let's do it with some slightly larger numbers, with bromine, for example. Okay, so a neutral atom again, no charge, and our atomic number is the bottom one, usually. In any case, it's the smaller one, and so that is 35 in bromine's case, and our mass number, you quickly see, is 79. So we fill that in there. Right, so you remember by now that the number of protons is the atomic number, which for bromine is 35. Remember that it's a neutral atom. All right, so electrons equals protons, so we can write in another 35 here. And the neutrons, all right, if we've got 79 nucleons, 35 of which are protons, then we find the number of neutrons just by taking our mass number from our atomic number, and that gives us 44 neutrons, like that. And so quickly we'll do the same for magnesium, also a neutral atom. So our atomic number is 12, our mass number is 24, number of protons is 12, the atomic number, and number of electrons is going to be the same as the number of protons, also 12, and then we have 24, which is our mass number minus our atomic number of 12 to give us the number of neutrons, which of course is 12. So hopefully that's clear. What we've done there is that we've worked out the number of protons, electrons and neutrons from the atomic number and the mass number that we get from the nuclear symbol as appears on the periodic table. So let's, before we move on, just have a quick look at ions as well. So ions, you'll remember, are charged particles, and they've got that charge by either gaining or losing electrons. Protons stay the same. Proton defines the atom or ion, but the electrons will have either been added to or lost. So let's have a look at an example. We've got let's have a look at bromine minus. Okay, so that's a commonly formed ion. Bromine in group 7 likes to get an extra electron. It's quite electronegative, so it's quite happy in this state. So it's still bromine. All right, so the number of protons is still going to be 35. Nothing has happened to the nucleus, so the number of neutrons is still going to be 44. All right, but it has a negative charge. Just put that in a different color. This is what it has, one negative charge. So the number of electrons is now not equal to the number of protons. And you'll remember that an electron is negatively charged itself. All right, so then the number of electrons is going to be the 35 that it started with, plus the extra one that it's got to give itself this negative charge. So it's going to have 36 electrons for bromine. So that's the same sort of calculations for a bromine ion. Now magnesium, our other example in our table, let's have a look at magnesium. Magnesium in group 2, it's a metal, so it likes losing electrons, and it's in group 2, so you'll remember that it has 2 electrons in its outer shell, so it likes to lose those 2 electrons. And if it does lose those 2 electrons, it's still got the same number of protons, so it's got a net charge of 2 plus. Yeah, so however, it's still magnesium. It's not changed into a different element. It's just an ion of the atom. So the number of protons must be the same because the protons defines the element. So if we had 12 protons before, we've still got 12 protons now. And same with the neutrons. The neutrons have not changed in this case. It's only an electron transfer. Okay, so the number of neutrons is still 12 as well. Right, but the number of electrons, okay, it's got 2 positive charges. That tells you it's lost 2 electrons. So the atom had 12, the neutral atom had 12 electrons. This one's lost, the ion has lost 2 electrons, so you can see that the electron number is 10. Just like that. So that finishes this particular little topic. We can move on to the next one. So we can move on to the subtopic of isotopes. And you may remember, you may not, that an isotope is an atom with the same number of protons, right, but a different number of neutrons. Okay, so by definition, if 2 isotopes of the same element will have the same number of protons, otherwise they'd be different elements, right? But they've got the same number of protons, right? But if they have different number of neutrons, then they are different isotopes of the same element. Let's have a look at a little example. We can see chlorine. Okay, so let's draw the chlorine symbol. And we have 2 isotopes of chlorine mainly. One has a mass number of 35. Now it's chlorine, so it has an atomic number of 17 protons. And that's chlorine 35. And it's sometimes written like this. Chlorine 35. All right, to illustrate that it's the isotope of chlorine that has the mass number 35. There is also another chlorine isotope, which is chlorine 37, written similarly like that, and it's still chlorine, so we've still got Cl as the symbol, and it's still chlorine, so it's still got 17 protons, right? But this time it has a mass number of 37. So making it a different isotope of chlorine. Okay, so let's just go back to chlorine 35, and work out the number of neutrons. So the number of neutrons is going to be in the same way. It's going to be 35, which is neutrons plus protons, minus 17 protons will leave you the number of neutrons. So the number of neutrons for chlorine 35 is 18 neutrons. And if we do the same thing for chlorine 37, the mass number this time is 37. And if we subtract the same 17 protons, that's this time going to give us 20 neutrons. So it's got 20 neutrons in chlorine 37 and 18 neutrons in chlorine 35. Now a little comment on properties. Now the chemical properties, which generally depend on the electrons and the electron arrangements, electron structure, the chemical properties are going to be the same for these two isotopes, and indeed for any isotopes of the same element. However, the physical properties that depend more on the mass, so that might be a physical property like rates of diffusion or density, those type of physical properties depend more on the mass, and so the physical properties can vary from isotope to isotope of the same element. Okay, just to make sure we've got it, let's have a look at magnesium this time. And magnesium naturally comes in three different isotopes: magnesium 24, magnesium 25, and magnesium 26. And if we work out the number of protons, neutrons, and electrons for each isotope, it's still magnesium, right? And so it's going to have, from your periodic table, it's going to have 12 protons. It's going to have 12 protons. And notice, I just draw a little square here. Notice there's no 12 there, because the 12 is implied from the symbol magnesium. All right, so it's magnesium, and to save you a little bit of time writing the 12, you can just omit the 12. But it's still magnesium, so that the atomic number is still 12, and there's still 12 protons. And in terms of neutrons, you can see there's 24 is the mass number, so 24 take 12 is going to be another 12 neutrons. 12 neutrons, and it's a neutral atom, so they're going to be 12 electrons. Okay, so that's the isotope 24 of magnesium. Let's do the same for the magnesium 25, of which there is about 10% of the naturally occurring magnesium on the Earth is magnesium 25. We don't know about the universe, so when you see these percentage numbers, that's the abundance of the magnesium on the planet Earth. And for magnesium 25, we've of course still got 12 protons, because it's still magnesium. But 25 take 12 is now 13, so we have 13 neutrons. And here it's still a neutral atom, so we've got 12 electrons. Now 11% of magnesium is magnesium 26, but it's still magnesium, so we still have 12 protons. But 26 take 12 now gives us 14 neutrons. But it's still a neutral atom in this case, and so we have 12 electrons. So hopefully with that example there and the chlorine one above, you can see what you need to know about isotopes. Which just leaves us to review our learning outcomes. The first of which was that we should understand that an atom consists of a nucleus containing protons and neutrons, and it's surrounded, that nucleus is surrounded by electrons. I think we know that. Let's give ourselves a nice red tick for that one. And then we were to be able to describe the properties of protons, neutrons, and electrons in terms of relative charge, proton plus 1 and electron minus 1, for example, and relative mass. That was when we spoke about atomic mass units being 1, 1, and for the electron 1/2000th of an atomic mass unit. So we covered that. And the third one was knowing the meaning of the mass number, protons plus neutrons, and the atomic number is just a proton number. So I think we can give ourselves another tick for that one. And then we were able to determine the number of protons, neutrons, and electrons in an atom. That was when we subtracted our atomic number from our mass number to give us a number of neutrons, etc. All right, so there we are. And lastly, we wanted to be able to explain the existence of isotopes, which we've just done for chlorine and magnesium. So there we are, we can tick those. Thank you very much. I hope that's been clear, and I'll see you in the next video.